Good morning, class. Here's a Calculus 1 Exam 4 review covering part of Chapter 4, all of Chapter 5, and 6.1 from 4.7 to 4.9, 5.1 to 5.5, 6.1. And here's 5.5, the substitution rule, 6.1, areas between curves. Integration by substitution is basically the reverse process of the chain rule. So want to differentiate that capital F of g of x gives you f prime, capital F prime of g of x times g prime of x. And as you know, capital F prime normally is represented by lowercase f. So if we let u be g of x and du is g prime of x dx, remember du dx is g prime of x, therefore du is g prime of x dx. So we can write this, and we end up with the following. Over any interval for which u equals g of x it's continuously differentiable at, and f is continuous on the range of this function, the following relationship holds. The integral of f of g of x, g prime of x dx. G of x is a choice of u, g prime times dx is du. It's the integral of f of u du, capital F of u plus c, or capital F of g of x plus c. That's the synopsis of the substitution and what it stands for. For example, as a warm-up example, if you want to integrate 2x times x squared plus 5 cubed dx, pay attention to the tip. Look for a function u or g of x anywhere in the integrand, and its derivative du or g prime of x multiplied by dx. Please understand du dx is g prime of x, therefore du is g prime of x times dx. So what we are dealing with here is a polynomial, and this is a polynomial. And when you have a combination of those, of course, 3 is not a big deal. You can raise it to the power of 3, but if it's 30, then you don't want to do that. You look for a choice of u, and then you're hoping du is there or multiple of that. Meaning, when you're dealing with polynomial functions, the more complicated one normally is the choice of u. In this case, u is x squared plus 5. The derivative of that is 2x. Du dx is 2x, therefore du is 2x dx. So what I like to do is to move the 2x next to dx so it becomes clear that this is u cubed. This entire thing is du. And therefore, we can use the power rule, which gives us 1 over 3 plus 1, or 1/4, u to the power of 3 plus 1, or 4, and a constant. And u can be replaced with x squared plus 5. And as always, we can differentiate this to check the work. It should give you the same thing without the dx. So that's the substitution, and pay attention to the tip that is given here. All right. We are dealing with a fractional expression. More specifically, they are rational expressions, but they don't even have to be rational expressions. Notice, even if I can factor the denominator here, since this is a 4x plus 1, won't have a factor of 4x plus 1, so there's no need for that. So if you let u be the denominator, anytime you have a fractional expression, if you can't simplify, the denominator is a choice of u. And if you differentiate that, you get 4x plus 1 times dx. So notice, if we put a dx at top, the top is du and the bottom is u. And this, you know it to be a natural log. And of course, a constant. Now replace the u, and we are done. By the way, we have to keep the absolute value because this expression can be positive or negative. Now, why did I put the two next to each other? Because I want you to compare and contrast. What is the difference? We have the same denominator. And as I mentioned here, even if I can factor it here, it won't have a factor of 4x plus 1. But you notice the top is 4 times x minus 1. So let's see if we can factor the bottom. Since they have the same factor of x minus 1, we can simplify, and we must. Anytime you're dealing with any type of a fraction, if you can simplify, you must before you move on. And now we are going to deal with this. If you choose the denominator to be u, then du is 2dx. So the top is 4 times dx, but you can say 2 times 2dx. Why do we put that? Because clearly now the top is du, the bottom is u. And these two, whether you put it in or out, it makes no difference. It's just a multiplier, it's just a coefficient. And this is basically the same as this one. It's a natural log. And again, you want to keep the absolute value because the expression of 2x plus 3 can be positive or negative. Now, what I want to do, I want to use the reciprocal of one of those two. I'm going to use the reciprocal of b, and I want you to compare and contrast in the same page. As you know, we did the factoring here, so the answer to this is the reciprocal of this expression. And now there is no need for a substitution because this gives us half of x. This gives us 3/4. And we know how to deal with those. X gives us half of x squared, with 1/2 becomes 1/4 x squared. This is 3/4 x plus a constant. There is no need for a substitution method, and that's the key. We need a substitution. We need a substitution. We don't need a substitution method. Well, basic integration, pay attention to the fact that the independent variable is theta. 5 gives you 5 theta. Now, cosine, the derivative is negative sign, but the integral of cosine is positive sign. So plus 2 sine theta and a constant. X to the power of 4, e to the power of x to the power of 5 minus 2 dx. Generally speaking, if you have exponential format, it is the exponent that is the choice of u. Generally speaking, when we have exponential, it is the exponent which is the choice of u. As you can see, the derivative is 5x to the power of 4. Therefore, du is 5x to the power of 4 dx. So to make it clear as to what we are dealing with, I'm going to move x to the power of 4 next to dx. So we see that this one is e to the power of u, but this one is not du. Now, the way I do it is that when a number is missing, I throw in a number and I undo it by its reciprocal. And you can only do that with numbers. So if a number is missing, throw in a number, undo it, and you get to this answer. In many texts, they do the following. They solve for dx. And they replace it here, and they get to the same answer. I believe either way is fine. This method that I'm telling you, it's a lot easier. You know the integral and the derivative of e to the power of u is itself, and you replace the u. And as always, you can differentiate the result to check your work, and we're done. This is a fractional format. This is a rational function. So why am I putting them next to each other? Because ultimately, any fraction, the first step is to simplify if you can. If you cannot, u would be the denominator. And as you know, if you differentiate this, you get e to the power of t. Therefore, du is e to the power of t dt. And now this becomes the integral of du over u, which is a good old natural log. Now, and you replace the u. Pay attention to the fact that this expression is always positive. Therefore, if you change this to parentheses, it's okay. If you have any doubts, you can keep it. We do the same thing here. First, it can't be factored out because b squared minus 4ac is not a perfect square. I hope you remember that from algebra. So a quick reminder. When we have ax squared plus bx plus c, remember the discriminant is b squared minus 4ac. If this is a perfect square, we can factor. If it's, okay, perfect. For example, like 25, 16, then we can fact. And in this case, it's not. In this case, it's not. So the denominator is a choice of u. And if I differentiate that, I get 2x plus 2. Therefore, du is 2x plus 2 times dx, or I factor out the 2. So 2x plus 2 dx. And I'm going to put the dx at top so it becomes clear what I'm dealing with. Dx is always, if you're dealing with a fractional expression, belongs to the numerator. So when I compare, I notice number 2 is missing. And again, 2 is a number. I can put in number 2, undo it with its reciprocal. Let's say I need 2/3, then I put 3/2 out here. Okay, so just a reciprocal. Reciprocal of a negative number, by the way, is also negative. If it's negative 3/5, then negative 5/3 is the reciprocal. So we rewrite it in this fashion. Again, you're dealing with a natural log here. You replace it and you're done. Now pay attention to the fact that this expression can be positive or negative. Therefore, you should keep it in an absolute value sign. I'm going to write the reciprocal of one of those. I want to write the reciprocal of the first one. And again, I show you that there is no need for substitution because, again, cut it into 2 pieces. This piece is 5e to the power of negative t, and this one is plus 1. Doesn't require substitution. This one we divide by negative 1 becomes minus 5e to the power minus t plus t and a constant, and we're done. No substitution. So compare and contrast. That's why I wanted to have all those 3 on the same page so you can see the similarities and differences. All right. Anytime ln x is involved, that is the choice of you. So if that's the case, you know du dx is 1 over x, therefore du is 1 over x dx, and I'm going to write it 2 different ways. 1 over x dx, this is one way to write it, or dx over x. And I write it so I want to make sure everybody can see that they're the same. So what do? Always rewrite your expression so it becomes clear what you're dealing. So I'm going to separate them into the following. ln x to the power of 2, and then 1 over x dx. I put it in this format. You could put it in this format. So this is u squared. This is du. And that is a simple case of a power rule, 1/3 u cubed plus a constant. And the u is replaced with ln x. We are done. By the way, it's important not to mix this up with ln of x cubed, 2 different things. So you must keep it in a parenthesis. That means ln x times itself 3 times. Now, I discussed the fractional expression. The first thing is to simplify. We can't notice The derivative of the bottom is the top. If you take the derivative of e to the power of x is itself, this one is itself times -1. So the top is the derivative of the bottom. So if this is u, the top times dx is du. Therefore, you're dealing with the natural log again. And of course, as a constant, and you replace the u. Again, if you lose the absolute value is okay. You should know this expression is always positive. You could change it to an absolute value. That's your choice. You want to evaluate the integral and notice this is the definite integral. The result is a number. Again, of course, this is 25 minus x to the power of 1/2. So this expression, not the square root, is irrational, is a polynomial function. So is this one. So the more complicated one is 25 minus x squared. That's the choice of you. Its derivative is minus 2x. Therefore, du is minus 2x. dx. We're going to start moving things around. We're going to move the x to dx. And in a matter of comparison, we see that this is square root of u or u to the power of 1/2. Ultimately, we have to go with that route. But what happens here, when you compare, you see everything is here except a -2. By the way, again, you can do that only to numbers. -2 is in there. Missing, plug it in. How do you undo it? Its reciprocal is -1/2. If x is missing, you can't do that. Okay, you can't do that with variables. You can only do it with numbers. So with that being the case, this is what we have. Notice 3 and 4, the original limits, lower limit and upper limit, pertain to the original variable x. But new variable is u, and I put a question mark on purpose. We're going to figure out what they are. But the thing is, you can't use the original limits. We're going to change this to u to the power of 1/2. This becomes 1/1/2 plus 1 u to the power of 1/2 plus 1. We keep this number. 1/1/2 plus 1. So this is 3/2. The reciprocal of 3/2 is 2/3. And you multiply by -1/2, you get -1/3. And I can replace the u and go with original limits 3 and 4. We can always do that. Or if I plug in 3 here, 3 squared is 9, 25 minus 9 is 16. So this is the new lower limit. I plug in 4 here, I get 16, 25 minus 16. The new upper limit is 9. So either way is fine. It's probably easier to deal with this guy. So we plug in 9. So minus 1/3 times 9 to the power of 3/2 minus 16 to the power of 3/2. I remind you that a to the power of m over n is the nth root of a to the power of n is the nth root of a to the power of m. And the third one is easier to evaluate, no need for calculators, because you know square root of 9 to be 3 and 3 cubed is 27. Then square root of 16 is 4, cubed is 64. We get minus 37. The product of these two gives us positive 37/3. Again, these are all elementary algebra. I wanted you to be expert. We want to evaluate this integral, the integral of ln of x plus 1 over x plus 1 dx as we go from 0 to 1. And remember, when ln is involved, that is the choice of u normally. And the u is 1 over x plus 1 dx. So again, you don't have to, but I'd like to make it clear. If I separate them in this manner, this is u and this expression, 1 over x plus 1 times dx or dx over x. On purpose, I'm writing them differently because one might write it in this fashion or in this fashion. This whole thing is du. And again, what are the limits? We can figure them out. So because this is 1/2 u squared, and I don't have a constant. But if I plug in 0, if I plug in 0 here, I get ln1, which is 0. If I plug in 1 here, I get ln2. And ln2 is an exact answer. You want to keep it as such. So plug in ln2 and square it. This one gives you 0. This is ln1. And ln1 is 0, everybody. And 1/2 of ln2 quantity squared. Why we keep it that way? Because that's an exact answer. And we rather deal with exact numbers in calculus, unless they ask you for so many decimals. Evaluate the integrals. I want to go over a theorem, the integral of symmetric functions if f is a continuous function from minus a to a. So if f is even, that means symmetric with respect to the y-axis. As we go from minus a to a, we can evaluate it from 0 to a and multiply it by 2. If f is even, so this part. Even means f of minus x equals f of a. We go from minus a to a. We can, because it's normally easier to evaluate it from 0 to a when one of the limits is 0, makes it easier. On the other hand, if it's an odd function, take a look. Remember, the integral doesn't represent the area, it represents the difference of areas. So if f is odd, the integral of minus a to a f of x dx becomes 0. F is odd means f of minus x is minus f of x. So the integral of minus a to a f of x dx equals 0. Normally, if you come across a case that takes a long time to evaluate, you want to look into the fact whether they are odd or even. For example, right here, we may notice that this function is an even function. So what is the function? Let me quickly show you. This is f of x, everybody. So what is f of minus x? Is minus x to the power of 6 plus 1, which makes it x to the power of 6 plus 1, which makes it f of x. We just proved the function is an even function, and therefore we are going to use this one. The reason is because it's easier to evaluate it from 0 to 2 rather than negative 2 to 2. It's really not too bad, but it's the case. So x to the power of 6, 1 over 7, x to the power of 7, plus 1 gives us plus x. We don't need the constant. We evaluate it from 0 to 2. Don't forget there's a 2 in front. And now the reason it makes it easier because 0 makes it 0. All you have to do plug in 2. Okay, so 2 times 1 over 7, 2 to the power of 7 plus 2. 2 times 7 is 14, added to 128 makes it 142, times 2 makes it 284 over 7. So you just add them up easily. I'm taking a common denominator and so on. Now, when you have a case which is a very complicated function, okay, like this, you can show it's actually equal 0. Why is that? Because you let this one be f of x, and you have to show it's an odd function, because we're going to go from -1 to 1, from -a to a. Pay attention to the limits. Anytime the limits are opposites, then look at this function. It may be that it's neither even nor odd, but if it's odd, makes life easy, it's 0. So why is this 0? You have to prove this is an odd function. So f of x is that. And to prove it's an odd function, just evaluate f of minus x. So tan of minus x plus over 1 plus minus x quantity squared plus minus x to the power of 4. So I hope you realize. So let me just write this one because I don't have it here. So if I want to evaluate f of minus x, let me just write it here. F of minus x means this. Tan of minus x over 1 plus minus x squared in a parentheses plus minus x to the power of 4. And notice tan itself is an odd function, so it's minus tan x. This is 1, this is plus x squared, this is plus x to the power of 4. So f of minus x equals minus f of x. And therefore, f of x is an odd function. And we just proved, let me just clean up the mess. We proved the function is an odd function. Therefore, according to this theorem, it's a continuous function. It must be 0. All right, we want to integrate this, and it means this thing 3x plus 7 to the power of 1/2. So that is the choice of you. This is slightly different. So I want to make sure that you understand, if you happen to have a deal like that, you can still integrate it. And du is 3 dx. So far, just like we've done it. Now, specifically on this one, I want to show you, they solve for dx. This is not what I do. So let me show you what they do, because it's simple enough. Really, there's not much of a difference. If you solve for dx, okay, right, solve for dx. Dx is du over 3, okay. And now, we can rewrite it in this fashion. And of course, u is square root of u is u to the power 1/2. This is what they do. What I do is different. So I want to show you what I do. So I just rewrite this. And over here, I notice 3 is missing. I plug in 3 and I undo it with 1/3. That's exactly the same thing. Now, I think rather than solving for that, this is what we did. I think it's a lot faster that you plug in 3 and 1/3 than going this route. Either way is fine. This we've seen it. 1 over 1/2 plus 1 u to the power 1/2 plus 1, and there's a 1/3 and a constant. And this is again being repeated. This is 3/2. The reciprocal of that is 2/3. And the product is 2 over 9. And 2 over 9. Now you replace the u and you're done. You can write it like this. Or you can write it like this. These are all algebra, okay? Because 3/2 is like 1.5. This is 1, and this is 1/2. You don't have to write it that way, but it's important to understand. Breathing. We can model the rate of airflow into the lungs by this function, f of t equals half of sine 2 pi over 5t liters per second, where t is the time in seconds. Find the total amount of air inhaled in one cycle, known as the tidal volume, if the cycle lasts 5 seconds. Well, the time for inhalation is half of the cycle, 5/2, and that means the total amount of air inhaled. It uses the accumulated change theorem, but 0 to 5/2. So whatever this number is, half of it, because in and out, we are assuming each one takes the same amount of time. That is the assumption. May not always be the case. That's why we go with that. And now it's a simple case. We want to integrate this from 0 to 5/2. The very first thing that we do, we are going to choose u to be 2 pi over 5 times t. The derivative of this, the derivative of that, that means du dt is 2 pi over 5. Therefore, du is 2 pi over 5 dt. Anytime we do substitution, we must write u and du, nothing else. So we are going to rewrite this. First, this 1/2, I'm going to take it out, so it doesn't bother us. Okay. Then dt, next to it, there is something missing. I compare, and I notice if I had 2 pi over 5 here, then I would have du, but I don't. So if I plug in 2 pi over 5, then all I have to do, the reciprocal of this outside. Remember, I took the 1/2 out already. So I plug in 2 pi over 5 in, its reciprocal out. Therefore, you're dealing with sine u du, and this 2, it's 5 over 4 pi. I'm not going to write the limits yet. We are going to figure it out. Now, it's 5 over 4 pi. Sine gives you negative cosine u. There is no constant. If we can figure out those, that makes a lot easier, life a lot easier than going back to that. So let's plug in 0. I hope you realize if you plug in 0 instead of t, obviously you get 0. So the bottom is 0. But let's plug in 5/2. So you get 2 pi over 5 times 5/2, and that's pi. So I can take this negative out and put it as negative 5 over 4 pi. Then cosine of pi minus cosine of 0. As you know, cosine of pi is -1, minus cosine of 0 is +1. So minus +1. So this whole thing is -2. And we get 10 over 4 pi or 5 over 2 pi. This is the exact answer. Now use a calculator. They probably want you to go with a decimal or two. They will tell you. So 0.80 liters. As far as the units are concerned, this is liters per second. This is the rate. So this becomes liters. So anytime we have a word problem, it's important to answer with proper units. Let's mix and match. We have this. I've noticed sometimes students make a mistake with that, so it's important to see that. So exponential functions and differentiate and sinusoidal functions. So if I want to differentiate, I want to remind you that we are going to, for the exponential, the answer is itself, you multiply by -2 minus the derivative of sine is cosine. So this one we multiply by -0.2. Okay, and minus is there. Sine gives you cosine, the product of those two, and we're very straightforward. Now, if you want to integrate, by the way, you have to have a dx next to it. Okay, you have to have a dx. And I want to remind you, when you want to integrate, then you divide by -0.2. That's the difference. And remember, the derivative of sine is cosine, but the integral is minus cosine. So minus becomes plus, and of course, a constant. So that was really the key. Okay. I wanted to make sure everybody understands. And 4 over -0.2. This is minus 4d over 2, which gives us -20 e to the power minus 0.2x plus cosine x and a constant. Now, what if this integration, we change it to an initial value problem with f of 0 being 20, which means we have a pair 0, 20. So we are going to replace the x with 0 and capital F of 0 with 20. As you know, this is 1, so we get minus 20 plus cosine of 0 is 1, and that means minus 19 plus c equals 20. So c becomes 39. You replace this, and now this is the initial value problem. Now remember, this is a general solution. This is a particular solution, a specific solution. The difference is, because of the c, we have a family of functions here, but now that this c is found, there's only one function. Let's switch gears and go to the area of the region between two curves. Let f and g be continuous functions, with f being larger than or equal to g of x. In other words, f is above g. Over some interval of a to b, then the area of the region between the two curves from x equals a to x equals b is as follows. So we are interested in this. Okay, this one is at top, the area under the curve. I hope you remember the area under the curve is exactly equal to that, which is the Riemann sum when we are dealing with a continuous function and a positive function. Remember that. So this becomes the area, and this becomes the area unless it's positive or negative at some points, and it becomes difference of areas. So the area under the first curve and the area under the second curve, the difference between the two. So we have area between f and g, area under the f function, area under the g function. Therefore, if you are interested in finding the integral of a to b f of x minus g of x dx, we find the integral of a to b f of x dx minus, we find this one, and that's the concept we are looking for. So what do we do? Well, the area of the region between two curves, here's the process. Number one, graph. Number two, find the points of intersection by setting f equals g, and so on. Number three, evaluate the integration. Now, there's a little bit more to it that I want to discuss. So first and foremost, notice this is called an increment of area, which has some width and it has some height. So this is the height. This is the width. W stands for, I'm going to call it DH. Now, this one, clearly the DH is DX. If it goes this way, there will be DY. And the height is f of x minus g of x. So The area of a typical rectangle is y of the t, means y of the top, minus y of the b, that means the bottom. Okay. Top. If you draw this typical rectangle, it makes it nice and easy. And when it's y of the top minus one of the y of the bottom, that dh becomes delta x. This y of t minus y of b is the h. And so I'm going to call it dA, and increment of the area is hdh. Always I'm going to call it hdh. dh is always either dx or dy. We will see that. The height is always y of the top minus y of the bottom, or y of the right minus y of the left. So y of the top minus y of the bottom dx, or x of the right minus x of the left dy. And so if it's f and g, it's the integral of a to b f of x minus gx dx. So that's the synopsis that we need. Here's a simple example. We want the area of the region bounded by this function. That means you got to graph this, the x-axis, and then 0 to 2. So the very first thing is to graph. I'm assuming nobody has any problem with that. You can even use a graphing calculator for that to speed up the process. So you graph it, and we want to go from 0 to 2. So here's 2. So if I were to shade the region of interest, this is the region that we are interested in, okay? Area under the curve. And so I like to mention this, that, you know, if you were to graph this, you need the location of a vertex. It's a parabola, x equals minus b over 2a, and so on and so forth. You can find the y-intercept, which is 0, 2, and take it from there. But anyways, a typical increment of an area has the formula h dh, h dh. Here's the height, okay, y of the top minus y of the bottom. So here's the height, which is the function minus this function, the x-axis, which is 0. And of course, as I said, this is the x. Look at this. You are going to move this along the x-axis. By the way, this, for example, would be another increment. If I'm here, this would be another increment, okay? So it depends. Just as an example, in all cases, the top is the function, the bottom is the x-axis. So therefore, this function minus 0, which is 2x squared minus 3x plus 2, as we go from a to b, we're going to go from a to b, 0 to 2. And understanding this concept is the most important part. The rest is elementary. This is 2/3 x cubed. This is minus 3/2 x squared. This is plus 2x. You plug in 2, 0 is nice and easy, makes it 0. So plug in a 2. When you plug in 2, you get 2 to the power of 3. 8 times 2 is 16/3. 2 squared cancels out. This 2 times 3 is 6, minus 6, and plus 4. And this makes it minus 2, and this gives us 10/3. I'm assuming nobody has any problem with the elementary algebra involved there. All right, we want to find the area of the region that is bounded by these two graphs. This is obviously a parabola, y equals x squared, and then shifts up by 1 unit, and y f of x equals 2x plus 1, or y equals 2x plus 1. is a function with the slope of 2, is a line with the slope of 2. So we're going to graph the two functions. I'm assuming nobody has any problem with that. So the blue one is the line of y or f of x equals 2x plus 1. The red one is g of x equals x squared plus 1. Now, we need to find points of intersection by setting them equal because we want to know the x coordinates of the two, and therefore we set the two equal. Obviously, one can cancel out, and then we move the 2x. We factor the x out. So x is either 0 or 2. So the limits of integration, a and b are 0 and 2. Now, we want to evaluate the integral. So first we write down this is 0. By the way, 0, how do you find the y coordinate? You put it into one of them. In fact, I highly recommend you put in both, because if they don't give you the same answer, somehow we made a mistake here. So that works. And then if you plug in 2 here, 2 times 2, 4 plus 1. If you put it here, 2 squared plus 1, both of them give you 5. So I would put them into both equations because I don't want to take a chance. And so we have those pairs. I want to evaluate the integral. So this is an increment of the area. Clearly, if you move this, and I'm going to show you another one as an example. This is another increment, everybody. So, okay. So if you look at that, you see this increment or this increment, so any other increment. The top is the blue function, the line, the bottom is the red function, the curve or the parabola. So dA is y of the top minus y of the bottom, and dx, because you move it along the x-axis. So this increment of the area, you move it this way. Therefore, it creates this width of dx. And so here's the height, the top f minus the bottom g. As I said, the width is dx. F is 2x plus 1 minus g is x squared plus 1 dx. And so we take the integral of this from 0 to 2. And now that we are here, it becomes mechanical, fairly simple. So we have 2x plus 1 minus x squared plus 1. These two cancel each other. And we get 2x minus x squared. 2x gives us x squared, and x squared gives us 1/3 x cubed. So x squared minus 1/3 x cubed from 0 to 2. Obviously, 0 makes it easy because it's 0. So just plug in 2. 2 squared minus 2 cubed over 3 minus 0. When you plug in 0, you get 0. So this is 4. This is minus 8/3. Four times 3, 12 minus 8 is 4/3. By the way, we're going to discuss the x of the right minus x of the left. In this case, it would work also, but you have to solve for x, okay? No need for that. But if you look at this example, we want to find the area of the region by the graphs of these two functions. X is 3 minus y squared. As you remember, when x and y, one of them has degree 2, it's a parabola. When y has degree 2, it opens sideways. And because this is negative, it opens to the left, remember. If it's positive, opens to the right. Because of that, we are interested in writing this one as x also. So x is y plus 1. So the very first thing is to graph those. So let's write this x equals y plus 1. It makes no difference, just a line, okay? A line, you pick up a couple of pairs, you graph this one. Just with 2 pairs, you can graph it. And this one, it's a parabola that opens to the left. And here's the graph. I'm assuming nobody has any problem with that. Now, the very first thing we need to do is to find points of intersection. So we set the two equal. So x is 3 minus y squared. X is y plus 1. So 3 minus y squared is y plus 1. And if I bring everything to the right, this becomes y squared plus y. This becomes minus 3. So this becomes positive, and this becomes minus 3, which results in negative 2. I'm going to assume everybody can factor into y minus 1 times y plus 2. So y is either 1 or negative 2. So we have the limits, in fact. But let's find the pair. Well, y is 1. So if y is 1 here, x is 2. Or you can use here. If y is 1 here, x is 2. So you want to make sure you check and recheck. So this point has 2 comma 1. Now y is negative 2. If I put the y negative 2 here, with 1 becomes negative 1. Okay, and I'm going to check it with this one. I hope you realize negative 2 and u squared becomes positive 4. 3 minus 4 becomes negative 1. So we have, as far as the x is concerned, goes from negative 1 to 2. As far as the y is concerned, goes from negative 2 to positive 1. And now, which one do we use? I want to make sure everybody understands what's going on. If I draw a vertical increment of area over here, clearly the top is y plus 1 and the bottom is 3 minus y squared. But if I draw it here, what happens? The top and the bottom are the same function. Therefore, I can't use an increment of area which is top to bottom. Instead, we use an increment of the area which is from left to right. So this is x up the right minus x up the left, because if I move this up here or bring it down here, let me just draw another one. Even if I draw it here, clearly in both cases, x up the right is the curve, 3 minus y squared. X up the left belongs to the line. So x up the right minus x up the left, dy. X up the right is the curve, 3 minus y squared, minus x up the left is the line, y plus 1. Okay, this is g minus f, right? G minus f, this distance, g of y minus f of y. And this width, it's going along the y-axis is dy. So we're going to integrate that from negative 2 to positive 1. So we simplify this. into, and I like to put it in descending order, minus y squared minus y plus 2. The first one gives us negative 1/3 y cubed. The second one minus 1/2 y squared, and the last one 2y. And I'm going to leave it for you to plug in number 1, evaluate it, plug in number -2, evaluate it, and convince yourself the answer is 9/2. There is a couple of steps of algebra involved or basic math. You just evaluate. You plug in number 1, minus you plug in -2, and it gives you 9/2. By any chance, you come up with the negative number, you're wrong. Something has gone wrong, because definitely this represents the area between the two curves. So sometimes H is x sub right minus x sub left. Sometimes H is y up top minus y up the bottom. So you want to be careful with that. Again, y of the top minus y of the bottom in this part fails. We want to find the area bounded by the following. It's a parabola that opens down, and this is the function g of x of y equals x. So the first thing is graphing. I'm assuming nobody has any problem with graphing. So if you draw any typical increment of the area, clearly the top minus the bottom. So let's find points of intersection by setting them equal. It looks like that. Okay. So let's 2 minus x squared, and then we bring everything to the same side because this is negative. Let's move to the right. And this one is x plus 2, x minus 1. And so x is -2 or +1. And so we can go with this, makes it easier. -2, -2, +1, +1. Those are the pairs, and make sure to check with this, okay? Because if it doesn't check with that, somehow we've made a mistake here. So we want the integral. Therefore, what is the increment of the area? dA is HDH, and HDH is y of the top minus y of the bottom, dx. This width is dx. Okay, so this is f, the curve, minus g, the line. So y of the top minus y of the bottom, dx. So dA, which is HDH, I can write here, which is h dh. And remember, dh is always one of the two, dx or dy. So this will move along the x-axis, therefore dx. So y of the top is the curve, 2 minus x squared minus y of the bottom is the line, simply x. And we are going to integrate this times dx from -2 to +1. And so this gives us 2x. This gives us minus 1/3 x cubed. This gives us minus 1/2 x squared from 2. And again, I'm going to leave it for everybody to do it on their own. So you plug in number 1. Gives you some answer. Minus, you plug in -2. Gives you some answer. And you come up with the answer here. Ends up being the same as the previous page. Now, we want to find the area of the region between these two graphs. And again, number 1, we need to graph it. So f of x is 3x cubed minus x squared minus 10x. That's this function, the cube function, and this one is the parabola. So what you really have to notice that this is the region we are interested in. This is the region we are interested in over here. F is at top of G. The cube function is at top of the quadratic function. In this region is the other way around. And that's the key we want to make a point of. So we want to find points of intersection, set them equal. These two cancel each other. I can move the negative 10x, move the 2x, make it minus 2x, and minus 10 is minus 12x. I take the x out, or better yet, 3x as a common factor. And x squared minus 4 is x plus 2x minus 2. Let's write this as 3x times x plus 2 times x minus 2. Therefore, there are three answers. This gives us 0, this gives us negative 2, this gives us positive 2. So those are the points. And we are really interested in the x coordinates, so that's good enough. But you can always check by putting in those values to see what you get. Obviously, 0 gives you 0. Just for the sake of argument, if I put 2 here, 2 squared is 4, minus makes it negative, and plus 2 times 2, that makes it 0. So that works. And you can plug in minus 2. And if you plug in minus 2, it gives you 4, minus 4, and minus 8. So this would be negative 2 comma 8. So, and you really want to check with this one to be on the safe side. So we want to evaluate the integral, and we have to look at an increment of the area. Clearly, over here, f is at top of g. Over here, g is at top of f. And so dA is y of the top minus y of the bottom. And that's why we have this here. Pay attention to the fact that you can't write f of x minus g of x. You have to put it in absolute value, because you have to know which one is at top at what point. So, for example, right here, f is at top. So when we want to evaluate this from here to here, which is from negative 2, this is negative 2 to 0, right? The x coordinate is negative 2 to 0, f minus g, this minus this one. But when we go from 0, okay, to 2, then it's the other way around. G, the quadratic function, is at top. So from negative 2 to 0 is this, okay? Because remember, if we put everything to the right, it becomes 3x cubed minus 12x, right? This is f. Let me just make sure everybody understands how we arrive at it. This is the f function, this is the g function, and believe it or not, this makes it f minus g from negative 2 to 0. So what makes it g minus f? The reciprocal of that. So we put negative in front of that from 0 to 2. So this part, h is g minus f. So plus 0 to 2, and the negation of that, minus 3x cubed plus 12x dx. I hope everybody is clear on that. So this gives us 3/4 x to the power of 4 minus 6x squared. We want to evaluate it from minus 2 to 0. This is minus 3/4 x to the power of 4 plus 6x squared. We evaluated from 0 to 2. So you plug in 0 minus, plug in negative 2, the same thing here. I'm going to leave it for you to do the algebra behind that. It ends up being 24.